everyone, in this video we are going to be talking about parallel and perpendicular lines. We actually use these terms a lot in real life when talking about like streets and how giving directions to someone, or when talking about driving, specifically like parallel parking. So anytime, for example, let's say a street and another street cross and they create a right angle, then they're going to be perpendicular to one another. Whereas if a street is parallel with another street, then it's like the next street over. So for example, like at the ocean front, Atlantic Avenue is parallel to Pacific Avenue. Those are just like one street across and they are parallel to one another. So let's go ahead and get started with the notes. So we are going to graph a line perpendicular to y equals negative 2x minus 6 that passes through 4, 0. So the slope that is given is negative 2, and we are going to graph a line that is perpendicular. So our new slope, our slope for this perpendicular line, needs to be the negative inverse. So think about it for a second. Think about what the negative inverse would be. And maybe you got it right. So since the original slope was negative, this is going to be positive, and then the inverse would be 1/2. Okay? So what we're going to do is now let's take a note about what it means to be perpendicular. So perpendicular, I hope you're either typing this or writing this down. Perpendicular, that means the intersection of the two lines forms a right angle. The intersection and a right angle is 90 degrees. Okay, so let's take the information we know. So we know that our new slope is 1/2, and we are going to be using the points 4, 0. So our x is 4, our y is 0. And so now we're going to plug this information into slope-intercept form in order to get the equation for slope-intercept form. So we know the y, we know the x, we know the m, and we're going to be solving for the b. So the y is 0, the m is 1/2, the x is 4, plus b. 1/2 times 4 gives me 2. And so I get negative 2 equals b. So when I write this perpendicular line in slope-intercept form, I use my slope that we got by doing the inverse, so 1/2 x, and then I'm going to use my b. So this is our slope-intercept form for this perpendicular line. Okay, so in red, I am going to graph this perpendicular line. I know my y-intercept, it's negative 2, and then my slope is 1/2, so I'm going to go up 1 over to the right 2, up 1 over to the right 2, up 1 over to the right 2. And I also want to go to the left so that I can make sure that my line is perfect. So I'm going to go down 1 over to the left 2, down 1 over to the left 2, down 1 over to the left 2. And then now I can draw a line, don't forget your arrows, through those points. Okay, I just want to see what my original line looks like and make sure that these look like they're perpendicular to one another. So in green, I'm going to graph my original line, and so its y-intercept is at negative 6, and then its slope is negative 2. So I can't really go anywhere I can't go down to over 1 because my graph ends. So I'm going to do the opposite and go in the other direction. So that means I'm going to go up 2 over to the left 1. So up 2 over to the left 1, 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 up 2 over to the left 1. And now I'm going to draw a line through my points. And don't forget those arrows. Okay, so as you can see, these lines intersect and they form a right angle. So that's how you can check to make sure that your work is right. And so we know that this equation must be correct. Okay, for this next one, it's asking us to graph a line parallel to y equals 3x plus 2 that passes through the points 1 and -2. So our original slope is 3, and since we're doing parallel, our slope is going to stay the same. So you can write off to the side, same slope. So that's how you know if something is parallel, if it has the same slope. When we have a parallel line, they are going to have the same exact slope. They're going to look really similar. However, it's going to be shifted a little bit from the original, and so they will never intersect. So parallel means that they will never intersect, ever. Never, ever, ever. Okay. So our new slope is 3, it's the same as the original, and then my x that I'm going to be using is 1, and my y is -2. Okay, so now we're going to plug this information in to get b, and then we'll plug b and our slope into slope-intercept form. So y equals mx plus b, I have my y, it's -2, I have my slope, it's 3, I have my x, it's 1, and I am solving for b. So I'm going to subtract 3, and so I get b equals -5. Okay, so now I'm going to plug this into my slope-intercept form, and so I have y equals 3x minus 5. So that is the equation of this parallel line. Let's go ahead and graph it. So my y-intercept is -5. I'm going to go up 1, 2, 3 over 1, up 1, 2, 3 over 1, up 1, 2, 3 over 1. Okay, and now I can go ahead and connect these points and draw arrows at the end. It would be great for you to go ahead and look at the other line, which we're doing in green, okay, to see that they're parallel, okay? So our y-intercept for that line is 2, positive 2, and again, we have the same slope, so we're going to go up 3, 1, 2, 3 over 1. If we do it the other way, we go down 3, so 1, 2, 3 to the left 1, down 1, 2, 3 to the left 1. Okay, let's go ahead and connect our points. So as you can see, the line that's green and the line that's red, they look really similar, and that's because they have the same slope. However, they have different y-intercepts, so they are never ever going to intersect. However, they do have the same slope, and that's why they look so similar. Okay, so now we are on the second page, number 1. It's asking us to find the slope of a line in slope-intercept form that passes through this point that is given and is parallel to this line. So the first thing that I'm going to do is I'm going to write down this line, but I'm going to put it in slope-intercept form. So I'm just going to write it down as it is, and then I want to get my y by itself. So I'm going to subtract 2x on both sides. When I do that, I get -y equals -2x plus 6. And then I'm going to divide both sides by -1 to get that y to be positive. So divide by -1, divide by -1. And so then we have y is equal to positive 2x minus 6. So this is in slope-intercept form. So our m in this case is 2. So that means our slope is 2. If we're doing a line that is parallel, then it's going to have the same exact slope. Okay, so now what we're going to do is we are going to plug this information in. So we have our slope, we have our x, which is -6, got it from the point, and then we also have our y, which is -9, and now we're going to plug this information into y equals mx plus b because we don't know what b is, so we need to figure out what b is. So when we plug this information in, so y equals mx plus b, we have -9 equals 2 times -6 plus b. So -12 plus b equals -9. You need to add 12 to both sides, and when you do that, you get b equals 3. Okay? So now we know all of this information. We know our b, and we know our slope. And so now we can fill out, and I'm going to do this in green, now we can fill out our slope-intercept form, which is y equals 2x plus 3. Okay, let's go ahead and do the next one. So this one is going to be a similar process, however it's dealing with a line that's perpendicular. So let's circle the important information. So we want the equation of a line in slope-intercept form that passes through this point and is perpendicular to this point. This line that they give us is already in slope-intercept form, but since we're talking about something that is perpendicular, so our original slope is -2, if it's perpendicular, we want the negative inverse. So negative inverse, okay? So since this is originally negative, it's going to become positive, and the inverse of 2 is 1/2. So this is going to, so I'm going to write this in red. So our new slope is positive 1/2. Then they give us x, which is 4. They give us y, which is -10. And now we need to plug this information into y equals mx plus b so we can get b, and then we are good to go. So I'm going to plug this information in, y equals mx plus b, -10 equals 1/2 times 4 plus b, that gives us 2. So a -10, we need to subtract 2 from -10, so I'm going to write that up here. So -2, so that means b is equal to -12. Okay, so in green, I'm going to circle the important information. So we have b and we have m, and now we need to put this into our equation. And when we do that, we are going to get y equals 1/2 x minus 12. So that is our final answer. Okay, these next two are a little easier because they're just asking us if these lines are parallel, perpendicular, or neither. So they give us two equations for lines. This second one, they don't have the +0 afterwards, but you can just pretend like it's there. It's not necessary either way. It's the same. So in order to figure out if it is parallel or perpendicular, we need to look at the slopes. So I'm going to circle them in red. Okay, so the slope of the first one is 1/4, and the slope of the second one is -4, and these are negative inverses of one another. So therefore, this is perpendicular. So that's your answer. these would, when these intersect, they would create a right angle. Okay, let's try the next one. Let's see if the next one is parallel, perpendicular, or neither. This one's a little different because they are not in slope-intercept form, so that's the first step for us, is to move them around and put it in slope-intercept form. So we can do that. So let's do that with the first one over here. So 2x plus 3y equals 6 minus 2x minus 2x. So then we have 3y equals negative 2x plus 6. Okay, now we need to divide by 3 on both sides. When we do that, we get y equals negative 2/3 x plus 2. Okay, so for this first one, I'm going to circle it in yellow. Our slope is negative 2/3. Let's try the next one to see if it is the same, or if it's the negative inverse, or if it's not at all. So here's the original. We're going to move some things around so we can get it in slope-intercept form. Okay, now we're going to divide both sides by negative 6, and I'm just doing like each parts individually. Okay, so when we are going to get y and then positive 2/3, because positive 4/6 would simplify to positive 2/3, and then positive 24 divided by negative 6 is going to give us negative 4. Okay, so these slopes look really similar, but one is negative and one is positive. So they are neither parallel or perpendicular. So your answer for this one would be, and I'm going to write it in green, it would be neither. Okay, good job, guys. Thanks for watching this video. I hope you have a good rest of your day.